I'm Anil Kumar, and here is a test question from Unit 3, Characteristics of Polynomial Functions. For each polynomial function, we are given two of them here. We need to find the name and behavior, possible number of turning points, possible number of zeros, and whether they are even or odd functions. You can pause the video, answer the question, and then check with my solution. Here we have two functions. F of x equals to minus 3x to the power of 5 plus 4x cubed minus 6. And then g of x equals to 2x to the power of 8 minus 5x to the power of 6 minus x to the power of 4 plus 5. Now let's begin answering them. The first one, we need to give name to the polynomial. Name is really dependent on the degree of the function. Now since the degree is 5, we can call it a quintic function, right? So the name is quintic function. Q-U-I-N-T-I-C, quintic polynomial. Now here the degree is 8, and therefore this polynomial will be called octic polynomial. End behavior. Now end behavior is really decided on degree and the leading coefficient, right? So the first one is odd degree, 5 is odd, and leading coefficient is negative, right? So in case you want to sketch this function, we are sketching for just the end behavior. Now negative leading coefficient means right side down, so right side is down, and odd means opposite ends. So that gives you the end behavior of the first one. And here it is even degree, both will face the same sides. Positive leading coefficient means right side up, right? So it will be both facing upwards. And so now we can write down the end behavior. So when x approaches minus infinity, y approaches positive infinity. And when x approaches positive infinity, y approaches negative infinity. That's the end behavior of the first one. And for the even degree function with positive leading coefficient, as x approaches negative infinity or as x approaches positive infinity, y approaches both same side, correct? So for both, y approaches positive infinity, correct? Now let's discuss possible number of turning points. Now let's continue with this kind of a graph here. If your function is to go from quadrant 2 to quadrant 4, it can go without turning, right? So it can go without turning, so that means possible 0 is possible here. Now let us say that this function turn once. Since it has to go to quadrant 4, it has to turn again, correct? So it cannot have one turning point, but can have two, right? So you'll notice that odd degree function will have even number of turning points, and maximum number of points which it can turn on is 1 less than the degree. So that gives us 0, 2, and 4. Now this is even degree, so it could go without turning, correct? So it could go with, it has to turn, so it could go with one turning. So the one is a number of least number of turning points. And if it decides to turn once again, let us take a condition where it decides to turn, then this is first turn and second turn. It has to turn again since it has to reach in quadrant 1. So the turning points will be 1, 3, 5, and 7. So these are all the possible number of turning points. Least being 1 and maximum number of turning points being 7 for octic polynomial. And for your quintic polynomial, it is going to be least is 0 and maximum be 4. Now let's talk about the zeros. Now if you have to go from quadrant 2 to 4, you have to cross the x-axis, right? At least once. So possible number least is 1, correct? Now degree 5 can have 5 zeros, right? Maximum number. So let's write down all the maximums. So I'll just sketch here approximately how many turning points to show you, right? So here we have, let us say 1, 2, 3, 4. Now degree 5 can have maximum 5 zeros. So we have, let me put 1 here. Now in this case, let's say all are linear. 1, so possible number of zeros are 5, right? Well, this actually explains both points. Maximum possible turning points are 1, 2, 3, 4, and maximum number of zeros are 1, 2, 3, 4, and 5, right? So it could have other combinations also. For example, I said this function could turn like this, right? 1. It could actually go and turn like this, and then can go like this and turn like that. So all numbers from 1 to 5 are possible for zeros, right? In this particular case, as you can see, the whole function may just go from quadrant 2 to 1 without even crossing the x-axis, right? So the possible number of zeros are from 0 to 8. Okay, so that is the possible number of zeros. Now the last part is find whether they are even or odd functions, right? It's not degree, it's functions. Now in the first case, if you see odd degree, and 6 has a even degree. So this one is neither, right? This one is neither. And about this one, even, 5 is x to the power of 0, it is also even. So this one is even, right? Now how to prove it? Even means that if I try to find what is g of minus x, I should get it same as g of x. Let's figure it out. So if I write g of minus x here, what do I get? I get 2 times minus x to the power of 8 minus 5 times minus x to the power of 6 minus x to the power of 4 plus 5. Now since all these powers are positive, even, minus x becomes positive. So we get 2 x to the power of 8 minus 5 x to the power of 6 minus x to the power of 4 plus 5, which is same as g of x. Now since g of minus x is equal to g of x, it is even, correct? So that's how you get it. For odd, let us find what is f of minus x for the first one, right? So in that case, we get minus 3 minus x to the power of 5 plus 4 minus x cubed minus 6. Now, if odd is the exponent for negative x, then what do we get? This will be negative, right? So it will be plus 3, so 3x to the power of 5. This becomes negative 4x cubed, and here we get negative 6. Now, if I take negative outside, I get minus 3x to the power of 5 plus 4x cubed. These two terms are same. However, minus 6 becomes plus 6. Do you see? So it is not really equals to negative of f of x, and therefore it is neither. So you have to show your work to find whether it's even, odd, or neither, right? But this explanation works if you have to just see the degrees. If all are even, then the function will be even. If all are odd, then the function will be odd. I hope with this you learn many things. All characteristics about polynomials are summarized in this particular question, and it is normally a question in your test. So have a good look at it, try to understand all the concepts, and then move on to the other questions. Thank you and all the best.